In this video, I'm going to explain how alert thresholds and failure counts actually work inside StatusCake, because this is where a lot of alert noise either gets created or eliminated. We're inside an uptime test here, and the settings that control this live in three places: check rate, confirmation servers, and crawl timeout. Let's break this down properly. Before we talk about thresholds, we need to define what a failure actually is. A failure happens when a check does not meet your configured conditions. That could mean the server didn't respond before the crawl timeout. It could mean it returned a status code you've defined as invalid, or it failed a content matching rule. The moment one of these conditions is met, that individual check fails. That is the starting point. Now, scroll up to check rate. This is how often we test. If it's set to 1 minute, we check every minute. If it's set to 30 seconds, we check every 30 seconds. This directly affects how fast multiple failures can accumulate, because thresholds are tied to time through frequency. Now, look at confirmation servers. If a failure is detected, we don't immediately assume downtime. We trigger a confirmation batch. 1 to 3 additional servers rerun that check. Majority rule decides whether the failure is valid. If the majority confirm it, we treat it as a real failure. If they don't, it's ignored. So confirmation servers filter false positives before thresholds even matter. Now here's the part that often gets misunderstood. A failure does not sit there waiting across multiple minutes before something happens. Let's use a simple example. The check rate is set to 1 minute, confirmation servers is set to 2. At 1 minute, the scheduled check runs. If that initial check detects downtime, we don't wait until the next minute. The confirmation batch runs immediately. 1 to 3 additional servers rerun the same check straight away. Majority rule decides whether that downtime is real, and if the majority confirm it, downtime is confirmed in that exact same window. We don't need 3 separate minutes to prove it, it's validated inside the interval. So what happens next? Well, once the downtime is confirmed, we're not trying to prove it again. We've already established it's real. Now the system simply continues running checks at your configured interval. If you're on 1 minute checks, we check every minute. Each check comes from a random IP within your selected monitoring region pool. And while downtime is present, the confirmation batch logic continues as well. So each interval gets validated, but the question has changed. We're no longer asking, is the outage real? We're asking, has it recovered yet? Which now leads us to our final question. When does the incident actually end? Well, the moment the check passes again and the confirmation agrees, the incident closes. So the life cycle is simple. A scheduled check runs, failure is detected, confirmation batch validates it immediately, downtime begins. Scheduled checks continue until recovery is confirmed. There's no slow accumulation of failures over multiple minutes before we acknowledge the issue. Validation happens quickly, and ongoing checks ensure we detect recovery just as consistently. So when people talk about failure counts stacking up over time, that's not how this works. Downtime is confirmed quickly inside the check window. After that, we're simply retesting consistently until recovery. Validate fast, monitor continuously, recover cleanly. That is the life cycle.